Hi guys, in my previous class I was trying to explain about vectors in two dimensions, how we represent vector in two dimensions and we represent vector in three dimensions. And we talked about unit vectors. I cap is unit vector along x-axis and j cap is unit vector along y-axis in two dimensions. Suppose if a vector is drawn in two dimensions, suppose let it be a vector so this is a vector. How we can represent this vector in terms of equation? If this p is a position vector, so the standard form to write position vector as r bar equal to xi cap plus yj cap. Here x is the magnitude along the x-axis and y is the magnitude along y-axis. And I cap and j cap are the unit vectors along x-axis and y-axis. And to find the direction, how can we find the direction? We can find the direction by using tan theta. Tan theta equal to coefficient of I cap upon coefficient of j cap, means the component along the y-axis upon the component along the x-axis. So these components we can write and we can find it. Let's try to find one problem in the two dimensions. Suppose the given that the question is like this: what is the magnitude and direction of I plus j? Magnitude and direction of a given vector just I plus j. So if this is a given vector I plus j, we need to find what is the magnitude and direction. First we need to find magnitude. So if you remember this formula for magnitude, if A is a vector of component ax I cap plus ayj cap, how can you find magnitude? Magnitude of A equal to under root of ax square plus ay square. So here we need to take only the corresponding vector magnitudes we need to take. So if you can see here, the what is the magnitude is given. If here nothing is given, here we can take 1. So j also 1. Now compare the given equation with the standard two-dimensional equation. So in the place of ax, how much I can get? I can get value of 1. In the place of ay, we can get the value of 1. So we can write magnitude mod a equal to square root of 1 square plus 1 square, which gives under root. Yeah, that's it. So this is the magnitude. Now what about direction? So the direction we can give that for direction. Now suppose this vector is making an angle alpha. Suppose this take an angle theta with x-axis. Then to find the direction, what you need to do? You need to draw tan theta at here. So from this triangle you get the tan theta. So how can I write the tan theta at here? From this given formula, direction tan theta equal to the magnitude of y component upon the magnitude of x components, ay upon ax. Here only magnitude only. So I can get 1 upon 1 which equal to 1. So if tan theta equal to 1, so this one I can rewrite as tan 45. Tan 45 degree. So you can remove both sides tan. So what we can get, theta equal to 45 degree. Now this is how we find the magnitude and direction. So the magnitude is given, ax equal to under root I got, and direction I got that theta equal to 45. So you need to remember these two formulas for two dimension, ax I cap and ay j cap. Here ax and ay are the magnitudes of the given vectors along x component and y components. And for direction, we will go for tan theta, that equal to ay upon ax, only the magnitude. So this is how we dealt with the two dimensions. Now when it comes to three dimensions, so in three dimensions, the vector representation. Suppose this is a vector in three dimensions. Suppose I draw a vector in three dimensions. Oops. Suppose if I draw a vector in three dimensions, so how we can represent this is a position vector P. If this is a position vector, the standard form of position vector R bar equal to xi cap plus yj cap plus zk cap. So here I cap and j cap are unit vectors along x-axis. Suppose if this time if I take this is x-axis and this is y-axis, this is z-axis, so this becomes k cap. So this is how we represent a position vector in the three dimensions. Other than the position vector, just like in the previous case, if a is a vector in three dimensions, how we can represent ax I cap plus ayj cap plus az k cap. And so here we need to find what is the magnitude of the ax, ay, az. So how can you get that? Ax equal to a cos alpha and ay equal to a cos beta and az equal to a cos gamma. So before that I need to mention the angle set here. If the position vector or if the given vector, if a given vector, this vector you have taken as a, so this vector is making an angle alpha with x-axis. Now this time I have to change axis, with alpha with x-axis and beta with y-axis and gamma with z-axis. Therefore we can write that ax equal to a cos alpha and ay equal to a cos beta and az equal to a cos gamma. Now let us ask a question. How to find magnitude and direction of a given vector in three dimensions? So I will take one three-dimensional vector and I will show how to find magnitude and direction of that corresponding vector. So let me take a vector right now. Suppose if a vector is given like this, find the magnitude. Find the magnitude of the vector, that equal to 2i cap minus 3j cap plus under root 3k cap. So this is a vector in three dimensions which is given. To this vector we need to find the magnitude. Suppose this vector if I can call as a, we need to find magnitude. It means only modulus we need to find. So to find the modulus of a given vector A, what we need to do? Use the formula square root of ax square plus ay square plus az square. Now compare the given vector in terms of standard vector notation. What is the standard vector notation? Yeah, this is the standard vector notation. Write it here. Now the modulus vector A equal to under root of, in the place of ax, what is the value? That is 2 square. In the place of ay, here the value is minus 3. So because if you compare the standard vector notation, the plus value will go there. So minus 3 square plus az value equal to root 3. So here is a root 3 square. So magnitude of vector equal to root 4 plus, here it is 9 plus 3. So I think I will get that under root 16. Yeah, 7 plus 9 it is 16. Its value goes to magnitude of vector equal to just 4. So this is how we find the magnitude of vector in 3 dimensions. Now let me change model. How to find unit vector? How to find unit vector? According to unit vector definition, suppose A is a vector. If A is a vector, its unit vector will represent with a hat, a cap. According to definition, a hat equal to a vector upon its magnitude. So this is the definition of unit vector. So we have to take the vector and we have to divide with its magnitude. So let's try to find the unit vector. Find the unit vector for 3i cap plus 7j cap plus 4k cap. So this is a given vector. Suppose if I take this as a vector A equal to vector, so 3i cap plus 7j cap plus 4k cap. To find the A unit vector, a hat formula, a vector upon its magnitude. So I know the vector, now I need to find its magnitude. So magnitude of vector A, what is the formula? Square root of ax square plus ay square plus az square. So get the magnitude, square root of ay value here equal to 3 square, and here it is ax, and the ay value here it is 7 square, and az value here it equal to 4 square. So just compare the given vector into standard vector notation. So that is axi cap plus ayj cap plus azk cap. Always remember the standard vector notation. So whichever the vector is given, we need to compare that with the standard vector notation. So then we can get the corresponding components, we can get it. So now we can simplify that. So I can get modulus value. So modulus of A equal to under root of 3 square, its value equal to 9, and 7 square, its value equal to 49, and 4 square, its value equal to 16. So if we can add this together, 49 plus 16 and plus 9, here it is 74. Yeah. Therefore, how we can write unit vector? Unit vector A cap equal to, first we need to write vector itself. So here vector equal to 3i cap plus 7j cap plus 4k cap. So that is the vector, the a bar value. So here the a bar equal to the whole vector, this much big vector, and upon, now what we need to write? We need to write about its magnitude. So modulus a. So what is the modulus a value? Here it is under root 74. So just I need to write at the down, so square root of 74. So this is the unit vector of given vector. So this is the unit vector what we need to find. So this is how we figured out the unit vector for a given vector. I hope now you are getting how to calculate unit vectors and how to deal with three-dimensional vectors. Let's try to add vectors itself. Let me take how to add vectors. Add vectors, three-dimensional vectors. We added vectors in terms of arrow marks, these to these, and finally we got this is the vector. But in equations, how we will add? Let us take me first. Suppose, so these are the four forces which are acting on an object. So force is a vector. The first vector is F1 equal to 3i cap minus j plus 9k, and F2 equal to 2i minus 2j plus 16k, and F3 equal to 9i plus j plus 18k, and F4 equal to I plus 2j minus 18k. Suppose this is an object. So in this object, four forces are acting. Maybe one is along in this direction. Let me take this F1, and another is along in this direction F2, and another is along in this direction F3, and another is along in this direction F4. And we need to find the resultant force. Since force is a vector, this will be add up. The F resultant equal to, how we can do, F1 bar plus F2 bar plus F3 bar plus F4 bar. So like this simple ordinary numbers how we add, so like that we can add it here. Similarly, to get the F resultant, in this case I need to add all this. F resultant F bar equal to F1 bar plus F2 bar plus F3 bar plus F4 bar. So first I will add all these k terms. So if you can look at, so this is minus 18k plus 18k, they both gets cancelled here, and these two will be add up. So 16 plus 9 I will get there at plus 25k cap. And when it comes to j, minus j and minus 2j, that equal to minus 3j and plus j and plus 2j. It means this total is getting cancelled. So here you can get that 0 j cap. And when it comes to I cap, so 9 plus 1 10, 10 plus 2 12, 12 plus 3 13. So 13 I cap. So see how easily we found addition of vectors. Just like numbers how we add, so the vectors also added just like that. So the resultant force. So this is the resultant force vector. And this is just a vector, but not the resultant force magnitude. To get the resultant force magnitude, what do we need to do? To find the magnitude, so we need to calculate its modulus. So modulus of 13 square and modulus plus 25 square. So under root 169 plus 25, 25, 625. So the total value what it comes, so that is the resultant magnitude in terms of newtons. So this is how we will find the resultant magnitude if one or more vectors is given. So we will add that to get the resultant. Let's take one realistic problem. The following problem says, to a person moving eastwards with a velocity of 48 km per hour, rain appears to fall vertically downwards with a speed of 6.4 km per hour. Find the actual speed and direction of the rain. So here we need to draw first two-dimensional, then the diagram gives us much information. Now this time I am not taking x and y axis, so this time we need to represent the direction. Person is moving towards east direction and rain is falling vertically downward direction, so this would be east, west, north, south. So this is south direction. Now first I would like to represent vectors of the moving person. So this is not at all visible. So let me change the color. Yeah, this is person velocity. So velocity of person along this direction is given 48 km per hour. And rain is falling vertically downwards. So this is the velocity of rain. So here it is 6.4 km per hour. So this is, I can represent that velocity of rain r. If these two vectors, this is the velocity of the rain with respect to person, they are using a word appears, that is not the original direction of the rain. So the velocity of the rain with respect to person, so this is velocity of rain with respect to p. So this is something is we need to more concentrate. Velocity of rain with respect to person. So in this case we need to find the resultant of the velocity of the original velocity of the rain. So in that case, first I will add vectors. Suppose if I bring the velocity of the person vector exactly down in the same, so these two vectors are added vectorially. Now I can draw the resultant vector direction from with this blue color. The resultant vector direction from here to here. So this is the vector addition. Now if this is velocity of rain vector, now my task is to find the velocity of the rain. So now we got that if this vector also same, if velocity of rain, that is v equal to r, so velocity of rain vector equal to, how did we get? We just combined. The velocity of rain vector is combination of velocity of person plus velocity of rain with respect to person. So try to understand the shortcuts what I am mentioning at here. So this is velocity of rain plus, so sorry, this plus is added at here. So we added these two vectors. Now if I represent velocity of rain in vectorially, so velocity of rain v suffix r equal to velocity of person, that equal to 48 km per hour, and here direction I'm using unit vectors I cap, that is along x-axis if I take this along x-axis, and y-axis if I take that along y-axis. And now for the velocity of the rain with respect to person, here I can use negative sign. So this is goes to negative y-axis, that is negative 6.4 km/h j cap. So I will leave the units and I will write only velocity of rain vector equal to 48 I cap minus 6.4 j cap. Now this is the velocity of rain vector. Now we need to find magnitude of the velocity of the rain. Now if you can compare this vector in original vector form, that equal to ax I cap plus ay j cap, if a is a vector. How can you find magnitude? Magnitude of a equal to under root of ax square plus ay square. Now under root of ax value here it is 48 square plus ay value here it is minus 6.4 square. So the signs also matters a lot. Don't try to write simply the vector expressions. If you miss negative sign, then our calculations will go wrong. So if you can do this calculation, so what the result we can get, that is the resultant of velocity of rain. So let me use calculator to do this. So the value here I got that here it is 2344.96. If I take this under root, so the velocity of rain equal to, the value here I got the under root value 48.42 km/h. So this is everything I calculated in terms of km/h, did not change in terms of meter per second. So that is the magnitude of the velocity of the rain. And to get direction, so we are using direction tan theta. So tan theta equal to the component of y component upon the component of x component. So here the y component in the given vector, the y component is equal to 6.4 upon the x component is equal to 48. If you do this division, 6.4 upon 48, so 6.4 upon 48, so this gives that 0.133. Simply I leave that theta equal to tan inverse of 0.133 value. If we can go for this tan inverse of that, so it is got a value theta equal to 7.594. So this is the direction of the rain. So this is how we take the help of vectors to figure it out, the magnitude and direction. So likely in the same case we can find in a realistic case, just like the location of plane or the location of satellite or anything in space to find out, or our geographical location. So this is the help of vectors. Now let's jump into one more problem. I will finish. The problem which is given at here, a position vector r equal to 3.0 t I cap and 2.0 t square j cap and 5.0 k cap. So that is the position vector of a location. We need to find velocity vector and its magnitude, and acceleration vector and its magnitude. So if r is the position, How we can write velocity formula? Velocity v equal to velocity vector equal to the rate of change of position dr by dt. Earlier we are taking position as x. If x is a position, what is the velocity? We can write that. So that is dx by dt. But here given r is the position vector. In vectors we represent r as a position vector. So it means if I do the differentiation for a given vector d by dt of 3.0 t I cap plus 2.0 t square j cap plus 5.0 k cap. So if I do differentiation to this given vector, I can get a velocity. So how can we do that? First we can separate it. D by dt of 3.0 times t I cap plus 2.0 d by dt of t square j cap plus d by dt of 5.0 k cap. Now remember, we can do differentiation to only variable, not numbers. So here which are the numbers? So to that all numbers we cannot do differentiation. So we need to do differentiation only the variables. Now I can add to this 3.0 and d by dt of t I cap and rest of this also 2.0 d by dt of t square j cap plus 5.0 times d by dt of k cap. So this is, you can write just like d by dt of 5. Otherwise nothing to do with the differentiation. D by dt of 5.0. Now for the first one, you can use this formula. D by dx of x, differentiation to the same element, its value goes to 1. And for the next one, d by dx of x square, we can use this formula, x power n formula, n times x power n minus 1. So these two formulas I can use to get it. So d by dx of x power n equal to n into x power n minus 1. So if you can use that formula here, 3.0 times, so d by dt value here equal to 1 times I cap plus 2.0 times, here the value 2 times t power 2 minus 1 times j cap. Here d by dt of, there is no variable at all, t value here equal to 0. So this term will become 0 at here. Now if you can rewrite this expression, so 3.0 I cap plus, if you can multiply 2 with outside, 4.0 t, because 2 minus 1 value becomes 1, and j cap. Here there is no k cap, k cap value goes to 0. Otherwise you can write that 0 times k cap. Now this is the velocity vector. So we got that velocity vector. So this is just a velocity vector. To find magnitude, so the magnitude of vector, so we can use same formula, square root of, so vx square plus vy square. Suppose if you compare the given vector v equal to vxi cap plus vyj cap plus vzk cap. So here we need to take only its magnitude, the terms only we need to take it here. Now if you can do it that, the magnitude of vector only, so therefore v bar equal to modulus square root of 3 square plus, we were thinking at 4.0 times t, so 4.0 times t is the total magnitude of square. So So v bar equal to square root of 9 plus 16 t square. This is the magnitude of velocity. Suppose in the given problem, they are given that when time t equal to 1 second, I do not mention that, when t equal to 1 second. So in the place of t, we can substitute that as 1. So if t equal to 1 second, here itself I can substitute there. Then the above expression will be changes. We need to find velocity at t equal to 1 second. So I can do it now, this expression, or otherwise I will remove this and I can write it here. When t equal to 1 second, the velocity v equal to 3.0 I cap plus 4.0 j cap plus 0 k cap, and we need to find when t equal to 1 second. So here there is no t because I substitute the given that t equal to 1 second, we need to find what is the velocity. So here the t value will be gone. So in this expression, take out t. So it will be changes simply. So velocity v equal to magnitude square root of 25, which equal to 5 meter per second. So that is the velocity, vector and magnitude. And next we need to find acceleration vector. Acceleration vector A equal to the rate of change of velocity vector. And right now I got the velocity vector d by dt of 3.0 I cap plus 4.0 t j cap, and k cap is 0, no need to mention it here. Now to find the acceleration magnitude, first we need to find the acceleration vector. So we can divide that d by dt of 3.0 I cap plus 4.0, you can write the front, and here you can do the differentiation for t only. Now d by dt of a constant, this value becomes 0, 0 times I cap plus 4.0, and d by dt of t, its value equal to 1, 1 times j cap. Now the acceleration vector A equal to 4.0 j cap. So this is the acceleration vector, and find its magnitude. So magnitude, its magnitude modulus of acceleration A equal to square root of 4, which equal to 4 itself, because it's having only single term. So this is how we apply vectors to given situation. So in this situation, we try to figure it out, the given position vector, velocity and its vector magnitude, and acceleration and its vector magnitude. How can you find the velocity vector direction? Suppose here is given that velocity vector direction. To find the direction, we need to find tan theta. Tan theta equal to y component, velocity y component upon velocity x component. At t equal to 1 second, velocity y component here given 4.0 upon 3.0. So tan theta equal to 4 by 3. So this is the direction.